So the most important thing really about standard deviation is understanding the concept. And that's because we end up using that concept throughout the rest of the course. Standard deviation is an important measure of a data set as we end up comparing that data set with another data set. We want to know, is their variances, are their standard deviations the same? Are they similar? Are they different? Right? And also their measures of center. So what ends up happening is we end up doing calculations with technology, although we spend a little bit of time doing it by hand. Here are some, this is sample, right? A comparison and contrast between sample and population standard deviations here. And so as you look at this here, if this was sample data, meaning that it came from a larger group, you get a sample standard deviation of 8.88. If this was data from a population, then you get a standard deviation or population standard deviation of 7.94. They're different again because of the n and n minus 1. This is adjusted, right? There's a slight adjustment in this one, and there's an unadjusted here version here when you divide it by n versus n minus 1. And so again, I wanted to show you how to use technology to get an answer like this here. Is again, this data was done for us already. So let's take a look at StatCrunch. That's ArtaStat. We get to StatCrunch here. Wrong one. There we go. StatCrunch here. Looking at this here, here's the data values that we were looking at. And so again, it comes to summary statistics, columns, and I'm looking at variable 1 at this case. And you have the values here. That's it. You just choose them. Standard deviation, right? There's other measures of spread. There's the range. Standard error is another one. Variance is another one. But the one we're looking at is standard deviation now. And then there's one called unadjusted standard deviation right there. And so when we compute those, you will see you get that 8.8 and the 7.9, which matches up with what we have here. Okay, and so that's how you would go ahead and do that. You want to try that with this data set here so that you get these numbers here. And then the interpretation of this data set, you would try that yourself. The annual compensation typically vary 3.17 million from the mean. Remember, standard deviation, right? You find the mean value, and on average, each of these values around 3.17 million, right? Because this was worth dollars here. Let's take one quick look at the ArtaStat here. Oh, let me copy and paste this here. There's that there, Control C. And so we want to do a quantitative exploration. It's a little slow sometimes. Once that goes in, you will go ahead and enter in that data, right? It's our own data. It's not from the textbook. There was no variable, so there's no name that goes with that. You enter the data in there, and so you end up with the 8.8. You end up with the sample here, and so that's, again, there's these slight differences with the ArtaStat. This is the free version, but not everything comes in. StatCrunch is the preferred, but you could still figure this out. There's other places to do these types of calculations. But again, ArtaStat will pretty much cover you, but in this case, we end up with the sample standard deviation. It assumes that this is all sample data here. And so looking at, again, the interpretation with that, because in general, we mostly only use sample. We have sample data. That's really what happens. If we have population data, it's not really statistics. And to finish this section here, it's about the understanding, right? Without doing any calculations and looking at these distributions, right? These histograms. How could we determine which have the largest standard deviation? And the way we do that, again, remember, is standard deviation is a measure of how far from mean the data values are. And this one have the largest standard deviation over here because it has more values farther away from the mean. Here you have, this one's the smallest because there's more values closer to the mean. Remember, these bars here represent a frequency, how often. And so the taller the bar, there's more values there. And so this one would be in the middle because these have more closer to the mean, these have more away, and these are in between. And so that's how you would determine, without calculating, which one has a bigger standard deviation. And then the last example is completed for us. Here, it's this discussion about thinking about how we use standard deviation, and on the next lesson we'll see this also. But once you have data like a mean and standard deviation, what we care about many times is, again, the interpretation of the standard deviation. So in this case, if there's an exam and the mean was 72.4, the standard deviation 11.7, what does it mean? It means the scores typically vary by about 11.7 points from the mean. So that means a lot of people scored 11. Well, again, there's a percent of students who scored above the mean by 11.7 points, scored below the mean by 11.7. So you have an idea of the distribution. And then this problem here leads us into the next section, thinking about if your own test score is 62, how far is your score from the mean? And do you think this is unusually low compared to the others, right? And so with this score here, you're 10.4 below the mean. And what you do is you measure that in standard deviation. So your score is within one standard deviation, right? If you think about it. 10.4, the standard deviation was 11.7. We're going to talk about this concept in the next section.